Good morning and welcome to the second webinar of our winter preparation series brought to you by WeatherWorks. My name is Nathan Wiles, Assistant Director of Sales and Marketing. Today we will be discussing the topic of leveraging snowfall data with our returning host and Director of Meteorological Services, Robert Reel. Rob will take you on a journey through WeatherWorks climatology and provide you with some important strategies to help reduce your exposure to winter variability. In all, the webinar will take roughly 30 minutes of time, and a video copy will be submitted to you following its conclusion. A copy of our Snowtistics report is also available for download on the left side of your screen if you are viewing this session from a desktop or laptop computer. Rob, the floor is yours.
All right, thank you, Nate. As Nate mentioned, yes, I am the Director of Meteorological Services. I have been serving the snow and ice industry for 12 years now, and along the way have led workshops at both SIMA and ASCA over the last couple of years, and have held many client education sessions as well. I'm very excited to be here with you today, and I sincerely hope that what you learn will help you this upcoming winter and for many winter seasons to come. As an outline, we'll first start with a quick recap of the 2020-2021 winter and also discuss some of the recent year-to-year variability. With that variability in mind, we'll talk about the utilization of snowfall climatologies and how they can help you better prepare, retain clients, and build more efficient contracts. We'll briefly touch on climate change and how it has, if at all, impacted the snowfall variability, and we'll wrap things up with the importance of accounting for mixed and unusual precipitation events, particularly sleet and freezing rain. As promised, we'll begin with a 2020-2021 winter recap, and as you see here, this was the seasonal snowfall across the CONUS US. Anywhere that starts to get in gray had at least measurable snowfall. Anywhere in blue had at least 6 inches. And once you get to the pinks, we're talking about 3 feet or greater in terms of overall seasonal snowfall. Now, a few things that stand out to me at least were there was pretty expansive pinks in the Northeast, signifying that the bulk of the area, particularly along and northwest of the 95 corridor, had a pretty decent winter last year. And that expanded through the Ohio Valley along the Route 70 corridor as well, where they saw a good 2 to 3 feet of snow for the most part. All in all, it was a nice rebound last winter back to near to above normal snowfall. The other area that sticks out is the expansiveness of the blues through the center and southern portion of the United States. Places like Arkansas, Oklahoma, Texas, many of those locations saw a good 1 to 2 feet of snowfall to go along with all that cold and ice that they saw as well. Now, on the flip side, we see quite a bit of blues towards the Canadian border, especially in places like Montana, North Dakota, and Minnesota, pretty much signifying a very lean winter there. They're expected to see quite a bit more snow than a foot or 2 feet of snow. And to go along with this, we have a few major cities highlighted. Places like Seattle saw over a foot of snow, while the mountainous west were kind of variable between above and below normal snow, depending on where you were. As you can see, Oklahoma City, nearly 2 feet of snow. Austin, Texas, almost 8 inches of snow. And towards the northeast, Newark and Boston coming in at about 3 to 4 feet of snow each. Again, pretty good snowfall, especially for the New York City metropolitan area. Now, compare this to just one season ago and take a little mental snapshot of what you see here. Here was the map from 2019 and 20. I'll go back and forth 1 or 2 times for you. And some of the biggest takeaways I have right off the bat is the areas that were quite lean last year through the Dakotas, Minnesota, the UP of Michigan, places like upstate New York and Maine were very snowy in 2019-20. That's really where all the cold air and all the snow hung out. Meanwhile, places like the 95 corridor in the Northeast were well below normal snow. Take a peek at the comparison again if you focus on places like Boston, New York City, or Washington, D.C. Quite a bit difference. And very similar through the Ohio Valley too. 2019-20 was relatively lean. 2020-21 was much better. And similarly, look at places like Arkansas, Oklahoma, and Texas 2 years ago. Some didn't even see any snow, or at least not measurable snow. So it was quite a bit different, where the jet stream dipped further south. Places to the south saw more snow, saw more cold air. And in the end, we saw big time differences in year to year. We saw quite a bit of volatility. And here's just a couple of the numbers to go along with the snowfall back in 2019-2020 winter, 2 seasons ago. Now, an easier way to compare that is to look at the direct change from the last 2 winters. Anywhere that's in a darker red or in a darker blue saw a greater change from year to year, signifying more variability. across the northern tier of the US. Big time departures, less snow last year than the year prior. Some places as much as 2 to 4 feet less of snow, particularly the Dakotas and particularly Maine. Meanwhile, it's a completely different story just to the south, especially around the I-95 corridor. Places like Pennsylvania and New Jersey, some places saw over 2 to 4 feet more snow last year than they did the year prior. And it's a similar story across the rest of the US. Most places saw at least a foot or two of change one way or the other, depending on where you are. Quite a bit of volatility from year to year. Very hard to plan and very hard to budget. Zoomed in just a little bit more on the Northeast and the Midwest, we have a couple of select cities, and the numbers here represent the difference in the last 2 seasons of snowfall. So for instance, on the top left, Baltimore, Maryland saw about 3 inches of snow in 2019-20, but they saw nearly a foot of snow last season, which was a 9.1 inch increase. Now the number that probably sticks out the most is Allentown, PA. They only saw about 5 inches of snow 2 years ago, nearly 60 inches of snow last year with a 53.2 inch differential year to year. I don't care where you are in the Great Lakes, the mountains, near the ocean, near Allentown, PA, it's hard to budget for a 53.2 inch differential year to year. That's very volatile, and that could happen anywhere. It happened to be in Allentown this past year, but it could be somewhere else next year. New York City, Boston, they weren't quite as extreme, but we're still talking 2 to 3 feet of variability where they saw more snow last year than the year prior. Now, it started to smooth out a little bit in Albany and portions of the Midwest, but we still saw over a foot more of snow last year in Chicago, Columbus, and Cleveland. So what we're aiming to address in this webinar is how do we better account and prepare for the volatility that we could see year to year when one season could be well below average, followed by a well above average snowfall season. And we also want to talk about, is this happening more? Is there any rhyme or reason? What can we do about it? And really the best place to start is to analyze a snowfall climatology report. Now, what is a snowfall climatology report? Well, in its most simple state, it's historical snowfall data spanning years, decades, or in some reporting locations over a century. So there's a lot of really good data available. And with this, you can determine snowfall averages, extremes, seasonal variability, event magnitude breakdown, and much more. There's a saying, knowledge is power, and I think that's very true when it comes to snow and ice. Obtaining these snowfall climatology reports are power. It will give you a leg up and increase your confidence when you're setting up contracts or headed into a winter season. Now, these are publicly available. If you look through NOAA, you can find some snowfall numbers. However, those are generally limited to reporting airports, which A, are often fairly scarce, and B, may or may not be quality controlled. So if you're looking for higher resolution data, for instance, zip code specific data with your location or your client's location in mind, with more detailed information, you're going to have to go through a private weather service. So let's look at the most basic form of a snowfall climatology. We have the last 30 years of data plotted in Boston, Massachusetts. At first glance, it doesn't look that helpful. It goes up and down and up and down. It looks like your heart rate after a busy winter season. So how do we make sense of something that's all over the place? Well, a good starting point is to look at averages. And the most common averages people will often use would be a 5-year, a 10-year, a 15-year, and a 30-year average. And a common question that I often get is, hey, Rob, what's the best average? Which one should I be looking at? I don't necessarily have a direct answer, which is, quote unquote, the best average to use. But I will say is that the bigger the data set, the more years in your average, the more normalized snowfall numbers tend to be, which end up being a true representation of what quote unquote normal is. So again, that's why you see the 10, the 15, and the 30 years all within a couple inches of each other. The data becomes more normalized. It starts to give you a truer sense of what normal snow is in Boston. With less data set, for instance, the 5-year, it can be more influenced by an anomalous winter or two. So, for instance, in 2019-20, Boston saw about 15 inches of snow, which weighed a lot more on the 5-year than on the other averages and resulted in that average being about 36, 37 inches over the last 5 years. So the short answer is there isn't necessarily a best number to go with, but the longer the data set, the more representative it will be over the long term. Now, you may, depending on your situation, want to look at the short-term averages and see what the recent trends are, and you may want to look at a 5-year snowfall climatology report. Or depending on your situation, it may be beneficial for you or for your client to show a higher or a lower number. So depending on what you're trying to get across, how you're trying to educate or build a contract, it may depend on which number is best for your particular situation. Now, I'm not going to try to argue whether the 5-year, the 10-year, the 15, or the 30-year is most representative for Boston. Instead, I'm going to cop out and I'm going to say that the average is somewhere between the 5-year and the 30-year. It's roughly between 35 and 50 inches. Now, going off of that, we'll plot on the right the area of 35 to 50 inches, and we'll highlight each of the years that fell within that. You may be counting those little red dots right now, and if you're double taking, it is only 8 dots highlighted red, signifying only 8 of the last 30 years have fallen within our 35 to 50 inch average, which is less than 1 out of every 3 years. It's really closer to 1 out of every 4 years, which may make you double take and think that that's an error, but more commonly than not, average snowfall, or at least near average snowfall, only happens, most locations, once every 3 to 5 years. It's not nearly as much as you may have thought. So the next question in your head might be, well, is the average even useful? Year to year, not so much, but over the long run, as we see, data becomes more normalized, and the average is a very helpful number if you're planning for at least 5 or 10 or 15 years. But year to year, there will be a lot of variability. There'll be some peaks, there'll be some variables, some peaks and some lows, and we need to account for that as well. We need to understand what our maximums are. For instance, in Boston, over the last 30 years, on 2 instances, we've seen over 100 inches of snow. And over the last 30 years, there's been 5 instances below 20 inches of snow. So we need to account for that. Sometimes will be normal, sometimes will be anomalously high or low, and sometimes will be somewhere in the middle. Don't forget to account for that in those extremes. So how do we get this sort of data, and how do we get it that it's not just Boston? I can get Woburn or Worcester, or for instance here, we're going to be looking at a Chicago, Illinois Snowtistics report. How can I get Waukegan or Schaumburg, right? Snowtistics allows you to do that. We have this data at a zip code resolution across much of the United States. It's a couple-page document, and it really could be the blueprint to better understanding your snowfall climatology and making more confident and accurate bids, and ultimately increasing your bottom line in the future. So we'll go through a couple different pieces of data here. I know there's a lot on this slide, but we'll start with the left, where it's tabular data, and it's showing you the monthly breakdowns and the seasonal breakdowns, as well as averages of snowfall over the last 10 years. This happens to be a 10-year report. You can get a 5-year report, you can get a 15-year report. On the bottom, there's averages, and I also want to point out something we haven't touched on yet, which is the median. The average, again, is just all the numbers in the data set blurred together, comes out with an average. The median is the midpoint of the data set. The median tends to be a little bit lower than the average, and the median quite literally says if there's 10 pieces of data, 5 will be above the median, 5 will be below, the median will be directly in between. And we see here that the median for Chicago, Illinois is 29.3 inches of snow, compared to, it's a little hard to see, but the average is 34.7. I won't really get into why the median oftentimes is a little bit lower than the average. The short story is there tends to be slightly more below average winters than above average winters, which is why the median is a little bit lower. But in general, the median may not be the worst number to work off of, and is a number, kind of another piece of data in your arsenal that you can use when you're preparing for winters. You have averages and you also have medians. Now, if we look over to the right, we see some prettier looking graphs. And the first thing I want to point out is on the top, where you see the seasonal snowfall amounts, this gray area signifies standard deviation. It's another term that I want you to be familiar with. One standard deviation accounts for what should happen 2/3 of the time. And you can see for Chicago, it's roughly between 20 and 50 inches. So if we were to look ahead, we could say that Chicago very likely is going to see 20 to 50 inches 2/3 of the time. And it's much easier to prepare for something that happens 2 out of 3 winters, as opposed to something like the average, which may only be 1 out of every 4 winters. So one of the biggest points I want you to take away is maybe focus a little bit less on that average number, which won't happen all that frequently, and start to look at averages in terms of a range. And a standard deviation is one great way to do that. Additionally, on the bottom, there's event magnitude breakdown, because it's not only important that we understand the snowfall climatology, it's also important, especially budgeting time and material, to understand how many salting, plowing, and significant events you could expect in any given year, or what the maximums and minimums could be. So a lot of really powerful data available to you in a Snowtistics report, which is all part of a snowfall climatology. So some quick takeaways right off the bat. First off, most winters aren't average. And because of that, be careful building your business around the norm. Oftentimes the norm won't happen. As we said, typically most locations, or 1 out of every 3 to 5 years, sees quote unquote normal snowfall. And because snowfall amounts can and do vary significantly season to season, balancing your contracts and your overall portfolio can ensure more consistent profitability. Now, I'm not necessarily a snow and ice contract expert, but I have spoken to many experts in the industry, many of which would suggest that balancing your contracts with both seasonal and per inch contracts can be a more stabilized way to ensure more consistent profitability. In addition to that, if you have good snowfall data, you can better understand what the range of normalcy is, as well as what your maximums and mins are if you're trying to include things like caps and floors in some of those contracts. Without that data, you're sort of just guessing in the dark. Additionally, volatility will decrease when reviewing a longer period of data. The risk decreases and the stability increases over the long run. Both are terms that you probably want, right? More stability, less risk, all sounds really good. How can we go about doing that? Well, if we can focus a little less year to year and focus more of the 3 to 5 to 10 year period, things would be more beneficial. And not just for you, but also to your clients. And I think this is something that you can try to do if you haven't before, is suggest a 3 or a 5 year contract with your clients as opposed to a 1 year contract. Like we talked about earlier, things tend to normalize with a bigger data set. We can get rid of some of the year-to-year volatility if we look out in time further, 3, 5, ideally 10 years, which probably isn't doable, but a 3 or 5 year contract very well might be doable, and it will help out you and your client with budgeting and likely normalize things a little bit more, so there isn't a huge winner or loser each year. And this could, in the end, really help your relationships last longer with your clientele. Lastly, zip code specific data as well as event magnitude breakdowns are critical if you're trying to budget out time and material at a location specific level. So those are some of the main takeaways so far. There's a lot more we could go over here. If you have more questions, we'll have some contact info that you can reach out later on in this webinar. But right off the bat, I think these are a few things that you can take away right here. Now we'll switch topics a little bit. I don't want to get political whatsoever, but I do want to address the question of, is climate change impacting our winters? We'll first start out with temperature. There is a clear temperature change across the globe and in most locations across the US in the upward direction. It's not necessarily extreme or minimum. It's somewhere in the middle where we're seeing an average of about a degree or 2 every century increase. And in this example, we have plotted the average temperatures each year since 1920 in both Boston, Massachusetts and Philadelphia, PA. And you can see they go up and down year to year, but the overall trend has steadily been up with that dotted line, about 1 to 2 degrees in both locations. Additionally, there have been less particularly cold days as the trend of highs less than 32 and the low temps less than 10 have similarly declined. Again, these numbers will vary a little bit depending on your location. We happen to show Boston and Philadelphia in this exercise. We also looked at a few other places in the Northeast and the Midwest, and they're all somewhat similar in nature. It's all data that you can obtain or you can request from us if you want some of your own data. Now, has that increase in temperature increased this snowfall? And on the other hand, we haven't seen much correlation in terms of the average snowfall being impacted by global warming. What we did is we took 30-year rolling averages. Basically every 30 years, we're looking at a new 30 years of data each year and averaging that together. And you can pretty much see that Boston, Massachusetts has more or less been consistent over the last century, and if anything, has actually dipped up over the last 10 years as opposed to down. Philadelphia, PA, very similar, pretty steady across this entire timeline, despite the overall trend in warming temperatures. So there isn't much correlation, at least we haven't seen any yet, across these two locations and across some of the other data sites that we looked at as well. But one thing that we did notice was that the variability has increased with more extreme years. So for instance, over the last 100 years, 8 of the 10 largest year-to-year swings have occurred in the last 30 years alone since 1990 in both Boston and Philadelphia. That's what these dots are representing. A year where there was a drastic change in snowfall accumulation, for instance, went from 80 inches to 20 inches, would have given a dot because it would have been one of the 10 biggest swings over the last 100 years. We are seeing more of those in the last 30 years than we had seen in previous times. Boston and Philadelphia were a little bit handpicked here. They're kind of getting the point across and showing that a little bit more on the extreme side. Most of the sites we saw, 4 to 8 of the greatest 10-year swings have occurred in the last 30 years. So it's tough to say that this is too statistically significant, and it will vary depending on your location of choice. But it seems like snowfall at least hasn't changed too much, but the variability has increased a little bit more, which again ties into the need to understand snowfall climatologies and be prepared for those particularly lean or particularly snowy winters, because normal isn't necessarily normal. Now, the last thing I want to go over before we wrap things up is accounting for mixed and unusual precipitation events. And those seem to be happening a little bit more as well. Now, I think everyone in this webinar will understand snow, sleet, freezing rain versus rain, but your clients or your customers may not. And it may be good to educate them on particularly the difference of sleet and freezing rain, especially if you're trying to incorporate this type of language in your contracts, which we will get into in just a moment. As a quick refresher, sleet are ice pellets. Those are literally the frozen balls that hit the ground. They're much denser than snow, typically 3 to 4 times denser than snow. It is not hail, though. It's a similar process. Sleet is something that will typically occur in the winter. Hail, if it occurs, will typically be in the summer. Freezing rain, on the other hand, is simply that. It is truly rain that falls to the ground and upon contact with a surface freezes on contact. That's the glare ice that can be very treacherous, and just a coating of freezing rain can require a lot more work than, say, just a coating of snow. Let's look at how both of these are measured. The standard practices are anything that's frozen falling from the sky, which includes both sleet and snow, are combined together to be called snow. The standard practices that the National Weather Service has created really since the beginning of measuring time is snow and sleet are combined together. They're both considered snow. Freezing rain, on the other hand, is reported separately as ice. Therefore, it is simple to determine ice accretion through the season. However, separating snow versus sleet can be more difficult. So if you want to separate ice, easily done. If you want to separate sleet, a little bit more difficult. Now, here's some approximations and rule of thumb of how much sleet or ice would have equated to snow. And there's some scientific backing behind this, but if you're ever like, man, I had this much ice, how much would that have been if it was snow? These are the rough equations. A 1/10 inch of sleet equals about a 1/3 inch of snow. So if you had 1 inch of sleet, you'd have between 3 and 4 inches of snow. If you had a 1/10 inch of ice, that's a 10-to-1 ratio. A 1/10 inch of ice is the same rough equivalency of 1 inch of snow. A coating of ice would be about a 1/2 inch of snow, and a patchy ice, which would be maybe some of your parking lots got covered in ice and became slick, others were wet, or if you're a road department, maybe some of your side shaded roads had a little bit of ice, or the hilltops had ice while the rest of them did not. That's what we're talking about when we say patchy ice. That equates to about a 1/10 inch of snow. Again, these are estimates that consider the average liquid water content, for instance, the density of each wintry precipitation type. I think they do a good job. I think they're scientifically backed. However, you may still be saying, I don't know, Rob, a 1/10 inch of ice equals 1 inch of snow. I take a lot of treatment to cover that 1/10 inch of ice, a lot of reapplications. Same thing with sleet, an inch of sleet, man, I got to push that. It looks like so much more than just an inch of snow or even 3 inches of snow when you equate it out. So you may be right. This does, I think, a good job. It's an initial stab at making some equivalencies, but it's not necessarily perfect. I think it's better than nothing. And what we'll talk about in this slide is how to incorporate that into your contracts if you don't already do so. Now, many contracts do include a T&M clause for ice. Some do not. Even if you do, though, you must clearly define what is ice and when the time and material kicks in. And again, remember, ice is synonymous with freezing rain and does not include sleet unless you clearly state that it does. So let's look at an example where 3 inches of snow fell, 1 inch of sleet fell, 0.2 inches of ice fell. In your CST report, You will have 4 inches of snow total because, again, snow and sleet are combined together. That's just the standard practice of measuring snow since snow began becoming measured way back when. And 0.2 inches of ice would be separated out from the freezing rain. So if you had a contract that does not account for mixed precipitation, you're going to feel like you're doing a whole lot of work, but you're only going to be able to bill for 4 inches, which probably is not ideal. So a simple suggested solution, which again, if you can talk to your client about it and they agree to it, would be that the contract accounts for at least ice. Snow and sleet would still be measured at 4 inches, but the ice equivalency would be 0.2 times 10 at the 10-to-1 ratio, would be roughly the equivalent of 2 extra inches of snow, and you might have 6 inches of billable snow at that point, or 6 inches of billable wintry mix, so to speak. Now, if you also account for sleet, which again is a little bit more difficult, you would all of a sudden get to 8 inches because you have 3 inches of snow plus the 1 inch of sleet times 3, get you 6 inches of equivalency of snow and sleet, plus that 2 inches of equivalency ice, get you to 8 inches of billable snow. Again, a little more difficult. You would likely have to request a special equivalency form from us to do that. But the middle one there, that where you account for ice, is very easily done. It's already separated in your CST reports, and it is a fair way of going about the contracts in the future. So as a session recap, snowfall has always and will always continue to vary season to season. And it is these ranges and extremes that make up the averages and can be critical to know your business and to know what these climate numbers are. Now, make sure that no matter how much snow falls, you have covered your cost of being ready to provide the level of service required by your contracts. Again, you're not only working when it's snowing, you're prepping beforehand, getting equipment ready. There's a lot that goes into properly maintaining a property or facility or whatever the case may be. So make sure that you're at least covered for that in case it is a lean winter. On the other side of things, accounting for the extra time and material needed in mixed events, particularly ice from freezing rain, can be highly beneficial and a relatively simple add, and it's one that oftentimes is overlooked. In terms of a snowfall climatology recap, with this data, again, for instance, getting a Snowtistics from WeatherWorks can help you improve the overall billing model and responses to RFPs, calculate more appropriate caps, floors, and refunds by looking at what the average range is, as well as the maxes and the mins. You can identify snowfall trends and determine a baseline or a trigger for time and material needed. I'd like to thank everyone for tuning in. I sincerely hope that you learned a few things. If you need anything else, there's a couple email addresses here. Sales@weatherworksinc.com can certainly help you out. If you're looking for a Snowtistics report, data@weatherworksinc.com would be the place to go. Again, I'm Rob Rilla. Thank you for joining me. Have a great day.